Hello, everyone. Thank you, Emil, and thank you, Murli, for a very personable introduction. I enjoyed it, at least. So my name is Yaniv. It's over there. I'll introduce myself a bit more in a second. But I was sitting in the hotel room last night, and I was thinking about basically this moment. And I see roughly as many faces as I was expecting or hoping to see. And I realized that I'm not exactly sure who are the people that come to these things. So I'd like to have a quick show of hands, just so I can also be introduced to you as much as maybe you'll be introduced to me. And you can raise your hand more than one time. How many people here are SREs? Okay. How many people are software developers? How many people are managers of SREs? Okay, yeah. How many people are managers of managers, executives, CXOs, okay? Okay. How many of you aren't sure if you are or are not an SRE? Okay, like a decent show of hands, okay? How many project managers? Product managers. Last question, I promise. How many data scientists? Right. Yay! Okay. Okay. Yeah, thanks. Thanks for that. So this is not my laptop, and I need to. Okay, now I know how to use it. Okay. So who am I? Thanks for introducing yourselves. Like I said, my name is Yaniv. I'm an SRE at Google. I've been there since 2013. I've done a bunch of things on infrastructure, and more recently on the Google Cloud Platform, GCP. And most recently, I'm GCP's quantitative reliability lead, which roughly means that I should help teams come up with a way to measure their reliability, right? Like try to put reliability into a number, and then work with teams to get the number to whatever is the appropriate point, like trading off other things, right? Like trading off cost or trading off other things. I raised my hand when I asked who's an SRE. It wasn't just to encourage you. I think I'm an SRE, but I don't know if I would self-identify as an SRE. I also raised my hand for many other things. Throughout my career, I've been equal parts SRE, a dev, and other product or project manager, and sometimes a bit of a blend of both. And I'm not just saying this to introduce myself. I think wearing these 3 hats or 3.5 hats to work every day, I think it's part of what I consider to be like how I SRE, right? I try to bring all of these identities to work every day. The opinions here are my own. I do work for Google, but I'm not here to speak on behalf of Google. I don't know that anyone can speak on behalf of all of SRE. I don't know that but I do owe a lot here to others, to my colleagues at Google and elsewhere. So thanks for all the good ideas, and everything's do what I say is kind of like on me. So, I don't know, we're a few minutes in, and I said the word SRE quite a few times. But actually, SRE is a pretty new profession. If you look it up in Google Trends, site reliability engineering, it kind of rose to prominence in the last decade and a bit. And when I meet someone and I say, hey, I'm an SRE, and they say, oh, that's great, I'm also an SRE, I always have this a little bit of doubt in my mind, like, yes, but are they the same kind of SRE as I am? Like, when they say the word SRE, do they mean the same thing when I say the word SRE? And so I thought, we're at SREcon, maybe it's a good opportunity to discuss that a bit, or at least for me to tell you a bit more about how I interpret the word, and perhaps have a chance to hear how you interpret it. So we have an acronym, right? It's site or system or service or whatnot, reliability engineering. I'd like to talk a bit about the reliability and about the engineering. If you look up in Wikipedia, right, like it says that engineering is using scientific principles to design and build things, and then they have a list of things, right? Like you can build a bridge and you can build a plane and all sorts of stuff. And as you'll see, my perception of SRE leans heavily on the engineering side. And throughout this talk, I'll try to explain and hopefully convince you why I think it's important to bring the scientific method or the engineering method to our practice. And what is our practice? Like, what are the things? Are we building bridges? Or no, we're building reliability. What does that mean? How do you apply the scientific method to reliability? So Lord Kelvin said almost 150 years ago that you can't really think about something properly unless you can put it into numbers, right? Like, unless you can put something into numbers, your understanding of it is sort of like meager, it's softer. And that you can't really practice the scientific method without being able to measure. And I tend to agree with that, and that's why I consider the ability to measure reliability to be the number one or the fundamental SRE skill. There are many SRE skills, many of them are very important, but unless we can agree on what is reliability and quantify it, I'm not sure I know how to SRE. It's hard, it's very hard, right? Like, reliability is a fairly fuzzy concept, and so to put it into numbers would require you to operationalize it, right? Like, that's the word they use in social sciences when you try to measure love or commitment or those kinds of things. You have to sort of like break them down and make sure that we understand them in the same way and prepare them for empirical measurement, right, through an experiment. It's pretty easy to say numbers, right? Like, it's pretty easy to say 3 nines. But I'd immediately ask 3 nines of what? If I told you I traveled 450 to come here to speak with you, 450 what? Like, did I travel like steps or kilometers or like miles or light years? Like, what's that all about? If I told you I bought a can of soda for 100 cents or euros or gold bars, like the price of this can it changes based on the unit I'll speak in. Much in the same way, when I hear that a service has a 3-9 SLO or 3 nines of availability, I have this question, okay, but what do you measure with those nines? Like, what do you mean? I don't think 3 nines SLO is enough to describe the reliability of a service, much like we'll build a social network maybe isn't enough to describe like the idea for a startup. Like, okay, but can you tell me more? Like, what do you mean by that? Again, I'm challenged by the laptop, but not anymore. Okay. So I do find that defining these terms and coming up to an agreement on what will those nines measure, it's important to crystallize everyone's thinking. Now everyone is on the same page, right? We all have a certain understanding of the word euro. If I said this can of soda cost me 100 euros, you'll know it's very, very expensive, even though many of us never met. And if I told you I bought a car for 100 euros, we'd understand it's very cheap, even though many of us never met. And actually, there's a big system in play behind the scenes to make sure that we all have the same understanding of euro, and we're able to convert it to pound. It's really, really complicated. There are many, many things, many very different things you could buy with a euro or with many euros. And there's a system in play to have these definitions. I would like to hope that we could have something as strong in our profession. So the SRE I aspire to be is someone who defines their work through the prism of measurement. It's someone whose job is to measurably optimize reliability versus cost. And basically, throughout the rest of the talk, I'll be explaining what that means. But roughly, it means that you start with a business objective, right? Like, you have someone in your business who cares about achieving a certain goal. And typically, again, depends on the type of business you're in and so on, if it doesn't have the words revenue, cost, or risk in it, I always think maybe you need to connect more with your business side and like better connect this goal with the business. And if it only has the words revenue in it, like we should have more revenue, I'm feeling maybe you need to connect it more with the reliability side. Like, can you please explain more how do you want to achieve a business goal around reliability? And then an SRE would come up with the correct measurement to describe whatever would be like the current situation of the goal. Right? Like, I'd like to sell more in the Asian market, and my users are complaining that it's slow. My users in Europe aren't complaining. So why is that? And what kind of measurement could help me express that? And then do any work necessary, really a very, very wide gamut of types of activities in order to have the measurement hit the goal within constraints, typically within cost, but could be within other constraints. I think I've tried to come up with the most succinct definition. Even though you could drop the word measurably, you could say optimize reliability versus cost, that'll be like okay. But I think the measurable piece and the agreeing on the units and the agreeing on the terms and the operationalizing reliability piece is so important that I spend 2 words on that. So sometimes I give this opening for a talk, and I can start seeing the audience's eyes glaze over. They're like, can you please get off the podium and grab a pager and start like SREing? Where's the Kubernetes in this? Where's the Prometheus? Like, is this guy even an SRE? What is he talking about, right? So I wanted to try and connect the big words to the real world. When teams tell me, get down from the ivory tower and grab a pager, it's often because they feel like overwhelmed. It's often because they feel like the operational overload is taking over them. And I really empathize with that. I think it's anchored in a false belief that you must trade off operations and reliability. Right? You can trade off operations and reliability. If we had a show of hands of who's on call, right? Like if I took your pager and added a die next to it, and you'd roll the die anytime the pager pages, and only if it's 6, you'd do anything. If it's anything less, you just silence it. I'm sure you'd have less operational load, but probably you'll be trading off reliability as well, probably. But you don't have to do this trade-off. It's one of the trade-offs you could do. So when you think you must do the trade-off, you imagine yourself as sitting on some sort of imaginary curve between operations and reliability. This doesn't have to be the shape of the curve. It could be like, differently shaped. It could have multiple inflection points. It's just a curve that was easy for me to draw, like on the slide, right? Like I don't know that this is the shape of the curve. Certainly not in your business. But I think that we're thinking that we are sitting on the curve. And we're not just on the curve, we're on the optimal front. We're on the best possible curve we could have. And so if you want to have more reliability, you have to suffer more operations. If you want to do less operations, you'd have to inflict less reliability on your customers. And I don't think that's the case. I struggle to remember a time in my career where I felt, wow, folks, we did it. We're on the curve. Nothing can be changed more. The only thing we could do now is change the alerting thresholds and make the pager go more. Changing the curve, moving the curve, is a huge opportunity, and I think it's a very common situation. There are cases where you can do less ops without sacrificing reliability and improve reliability without taking on more operations. And so I sometimes think that the words around describing our operational acumen, right? Like this person is a great on-caller, right? Like they're great under pressure. All things being equal, they're good things to have, they're good skills to have, but I'm not sure I would characterize them as the defining skills of an amazing SRE. You don't typically move the optimal front or get closer to the optimal front under pressure. What do you call this movement? You call it engineering. At least that's what I would call it, right? You sit in the AC, nothing is paging, you're sipping your coffee, and you're moving the front. And I think this is the SRE I aspire to be, right? I aspire to be moving the front. Okay, this is still very theoretic, Yaniv. It's early in the morning, we flew, it's cold. Can you please connect it to something that works in our life? Okay. Let me bring in a true story from the mid-early 90s about a server in a small business that had one hard drive, and the hard drive crashed, and a young and aspiring sysadmin had to run somewhere to a cupboard and get another disk and restore the thing from tape, and the business was down for the entire time, and bring the server back up online. To those who didn't realize it, I was the young sysadmin at the time. Anyway, and it's a classic tale of ops, and I imagine that many of you were the person in this situation, depending on how early were you working in history, right? Maybe in 2015 or 19 it's less of a common story, and also maybe how irresponsible you are. But there is a story of operations here, right? Things were working. And then suddenly a very bad thing happened. And then we had to rush off to the cupboard, and we were under pressure, and nothing was working, and the CEO, it was a 25-person company, but still it had a CEO, and they weren't happy about it. It's kind of easy for us to imagine what could have been done in advance, right? What kind of engineering could we do to make this a non-issue, right? Why didn't the server have another disk? That would have been a great idea. Right? Because a disk fails typically, the numbers vary a bit and so, but has roughly an annual failure rate of 1.5%. If you had another disk, you'd have 1.5% squared. I'm cheating. If you had another disk, and assuming that you configure the RAID perfectly, and assuming you don't fat finger anything, and assuming you don't have correlated failures between the disk, like floods or electricity zaps or whatever, and assuming the RAID software has no bugs, none of these assumptions are true. But still roughly, right? You should get closer to 1.5 squared. That's much more reliable. You didn't do any ops, right? You configured the RAID before the server was brought online. That wasn't operations, but it is more reliable. Now, so don't replace the disk. Don't go to the cupboard, get a disk. Go to the cupboard, get 2 disks. And your boss would say, wow, but that's twice as expensive. You'll say, but look at your business, and they won't argue much, right? Like they have a very visceral example of what could happen if they don't have 2 disks. Plug them both in, configure the RAID. That's a bit more complicated, right? Like that's a bit more expensive. We had some CapEx, some capital expenditure there in typing the commands to configure the RAID. But still, it may be worth saving the company from sitting idle for 4 hours. And you can do this without the disk failing, right? You can do this in advance. You could go to your boss and say, hey boss, listen, I could build a server for $1,000 and I could build it for $1,200, right? By adding another disk. The boss would say, what will I get out of it? And you say, you'll get nothing, you'll get more reliability, right? Like nothing would change in the behavior of the server, just that it would be gooder. And if the boss argued, you can bring out the napkin and say, okay, here's the cost of a disk, and here's the annualized failure rate, and here's the annualized failure rate squared, and I'm neglecting some of the maths here, and here's the cost of an outage. And if you put this into a risk return on investment formula, you'd end up that if an outage costs you, I don't know, $14,000, $15,000, and a disk costs $200, and these are roughly the numbers, it's worth it. Right? And you could try to convince your boss of that. Congratulations, this was reliability engineering. No operations involved. No one had to hold the pager. So I think us reliability engineers, we really don't have that many tricks up our sleeve. It's really quite simple. We have 3 astonishingly simple tricks. You have a thing that needs to use a resource. So you provision 2 of the resource, or 7 of the resource, or some more of the resource than you would nominally need. And now you're trading off costs, right? Like the boss is paying for the extra disk, or the extra server, or the extra fiber deployment, or the deployment in another region, right? It doesn't have to stay in like the early 90s or whatever. We can bring it to the 21st century. The other thing you could do is you could trade off quality. Right? If in some types of systems, in some architectures, I don't know, you're building a search index and you're storing the index on 10,000 disks, maybe if one disk fails and you can keep on serving the index from the other 9,999 disks, maybe that's a little better, but not better enough. Like it's still good enough for us to say, okay, I'm trading off quality and I'm not paying for the extra disks, right? And then I'll replace the disks and like rebuild the index afterwards. And finally, if errors are transient, and everything is transient, right? Like as far as we know, the universe is transient. So if you're willing to wait long enough, sometimes another few milliseconds, sometimes maybe a few eons, you can also trade off latency for reliability. So these are, I think, the 3 basic trade-offs. They're pretty straightforward, but they're very versatile, and we can do a lot with them. But all these trade-offs you apply them with a hidden cost of added complexity, right? That we sometimes ignore. You remember all the little imperfections in the maths before? 1.5 squared. It's not really 1.5 squared. What about the firmware bug? And what about fat fingering and all those things? So when you compound and compound and compound and compound and compound the complexity, and you end up with something that isn't a Novell network server for like 25 people, but rather is a global deployment across regions and servers and services and so on, all of the little imperfections in the model, they could make room for the emergent behavior. And you don't know how to do the maths up front about how reliable a thing will be, or at least it can be very, very difficult. And the emergent behavior shows up, and well, after it's shown up, the root cause analysis would tell you what 5 factors and what 5 things that you didn't take into account combined together to create this big outage. But in advance, it's very, very difficult to explain to your manager why do you need the extra $200 for the disk, or the extra $15 million for a month for the extra regional deployment, or whatever it would be. We have more patterns, like more sophisticated patterns, that I think are either like changing our practices as humans, or composing the little trade-offs I've explained before, right? Like you're trading off cost and latency, you're trading off like quality and something. I don't know that it's worthwhile to describe the 8 that I've chosen to put in the slide. We have many, many more of those patterns. Typically, we compose together the fundamentals, or we try to make sure that our practices won't break the promises that we've tried to have, right? Like partitioning is a very popular thing. You have many kinds of customers. They want to use the same service. They want to use the search index, and it's roughly the same search index, but you're partitioning them from one another. So if one of them has a very, very bad query that crashes the server, they would only crash like one shard. Like that's one thing you could do with partitioning or sharding, or I don't know, like I'll describe just one more, the breaker pattern, right? Like kind of helps you rein in the emergent behavior of overload. When many callers are trying to access a resource and the resource is already struggling, maybe it would be good for the callers to kind of like take a step back and stop trying to call the resource for a certain amount of time, and so on and so forth. We use these patterns to try and rein in the complexity, to try and to reliability engineer. We think, if I'll be deploying a fail static across the fleet, I've done a meta-analysis of incident reports, and I think it would get me to like this much value. But suddenly the math is much, much more difficult, and it's much less straightforward than, $200, add a disk, 1.5 squared, let me do the math. An outage should cost you $15,000, otherwise it's not worth it, right? Like something like that. Suddenly it's much, much more difficult. And this difficulty brings us to an age-old tension, I think, like since before site reliability engineering, between two forces of technological advancement, right? Like the force of innovation and the force of reliability. One of them is sort of like proactive, wants to change, wants to bring us into the future. Here's the river. There's no bridge over the river. We want to have a bridge. And the other one is kind of like trying to make sure we keep having what we had. There is a bridge over the river. I'd like the bridge to stay exactly where it is, even when, I don't know, like the Legion is going over the bridge. Now, left unstructured, the tension between these two forces can be quite damaging, right? Like you don't build an amazing airliner by having the VP of drag and the VP of lift meeting at the CEO's office and arguing, right? Like they try to have formula, they try to have some kind of structure around the conversation there. And clearly, every business needs a mix of both of these things, right? Like you can't be 100% reliable with zero innovation. We're not doing anything. We're only keeping what we had, well, then you have nothing. Or if you have something, you'll stagnate. Or we're only innovating, like we're building new things all the time, and they never, ever work, not even once in the lab. Well, maybe that's not good either, right? Like we need to find some kind of balance. This brings me back to the ability to measure reliability. If you had a measurement of reliability, that would give the two VPs arguing at the CEO's office an opportunity, like a language and a mental framework to think about, right? Like we're aiming for this much reliability, for 7 reliability, 52 reliability, for whatever is the unit that you've agreed on. I spoke about how difficult it is to come up with the units. And at the moment we're below the unit or we're above the unit. If we're above, maybe we should be spending more on innovation. If we're below, maybe we should be spending more on reliability. And this kind of thinking is true for a Fortune 500 company, and it's true for a tiny startup. Maybe the precision of the discussion, maybe the value of more precise measurement changes in a bigger or in a small company, or as the decision-making process is, the parameters of the decision-making process change. But still, the way that we're thinking about it, it stays the same. So what would be this measurement? What would this much mean? How would we come up with the measurement? At least in Google SRE, we use the term error budget, right? Like you come up with a measurement, and then you said, this is the appropriate amount of reliability. We're aiming at this. We're not looking to exceed it too much, right? That'll be wasting some of our innovation ability. We don't want to miss it, right? Like that would be damaging our business prospects by not being reliable enough. We want to roughly hit the error budget. We want to be this much reliable and that much unreliable. We try to have a goal, and this is the thing that helps us find balance. It's not just good to help us find balance and allocate resources more efficiently. It also changes the very nature of reliability work, right? Like I said before, that reliability is the force that wants to support and react and preserve. I don't think it has to be that way. I think we can all innovate and drive change and move into the future. When you have such a measurement, you can, absent of any emergency, right? Like there's no outage. You can look at the track record of reliability across a fleet of things or across a lot of time and say, over the last year, we had 42 reliability, and we've agreed that we'd like to have 50. So even though nothing is burning now, let me go and engineer and make things more reliable. Let me plop in another disk in the server or deploy to another region or like deploy a pattern or whatever we think is the right thing. So what would it look like? Well, 42 of what, right? Like how do you measure the units of reliability? I think there are two very common units that we talk about. One is MTBF and MTTR, mean time between failures and mean time to recover. Could also be another aggregation function, doesn't have to be mean, median, or other things, so I'll just call them TBF and TTR. That kind of assumes that the system is okay most of the time, but then there are failures that make the system not okay. We want the distance between failures to be large, and we want the duration of the failure to be small. And the other approach is what we, I don't know that we have a good name for it, the nines, the success rate, sometimes uptime, right? Like in the context of 99.95% things. We look at lots of events that happen in the system, lots of discrete events. We're sending queries to a microservice, and some of them succeed and some of them fail. And we look at the good queries over the total number of service. And typically, for some reason, we all got hung up on seeing nines in that number, right? Like if it's not 2 nines or 3 nines or 4 nines or 5 nines, you're probably not doing it well. I'm not sure we have to be hung up on the number. Both of these approaches, I said it's hard, and I don't think I can solve it for you here with a slide. It's still hard, right? Like here, you've seen this, great, you can go and measure reliability. No, you can't. It's hard on the left-hand side because it's very difficult to come up with a definition of failure. And this is not just hard for us, this is hard I think, for other reliability engineers as well. I came across a thing called Annex 13 of the International Civil Aviation Organization standards. It's a body of standards, a UN agency that defines standards for international air travel, including safety standards, right? And I came across their definition of an air accident, which you'd imagine is a pretty straightforward thing. We know what is an air failure for an airliner. Turns out it's 200 pages long. It's 200 words long, sorry. It's 200 words long. If I wanted to read it out to you, it'll take me over a minute just to explain what is an air accident. And it has these sentences like, came in direct contact with any part of the aircraft, including parts which have become detached from the aircraft. And you think about it, you're like, there must have been an incident report behind this, right? Like someone had to think, wait, but if the wing is now no longer connected to the plane, what does that mean? And actually, it could be way smaller, right? Like if this screw fell from 30,000 feet and did something bad, is that an accident, or if it isn't an accident? And these decisions are hard because they're not just reliability engineering decisions, they're business decisions, right? Like when we come up with that decision, now we have to do more maintenance on the screws, or we have to make the wing 2 millimeters thicker, or we have to add another valve or whatever, and that could have very big implications in real life, right? Like it's no longer the $200 for the disc, it could be another region, it could be 200 additional millimeters on the wing, and whatever is the fuel ramifications of it, and so on. So really what you're doing is you're making business decisions. And all of us are making business decisions where we're trying to come up with a definition of what is reliability. I didn't say, but the nines are also difficult, right? Because you have the challenge of aggregating the individual events into something that is business meaningful, right? If I told you that I have a server with 99.997 success rate, you'll be like, oh, okay, that sounds pretty good. But the 0.003 is only for the method of checking out. So customers can do everything they want in the shop. They can browse and they can do anything they want. They cannot check out. Is that still okay? No, it's not okay anymore. Right? And suddenly, like the 4.5, I don't know, how many nines did I say? 4 nines and 7 aren't as impressive as they were before. So I think if we want to earn and retain leadership's trust in organizations, to earn and retain product management's trust, to be connected to the business, we need to understand that the nines aren't enough, right? Like you can talk about reliability on the prism of nines. You have 2 nines. I rolled the thing out, and like that's what I had. And maybe it didn't end up in 2 nines. Maybe it was 72. And then I spent a bunch of time optimizing a metric, and I optimized and optimized and optimized, and I got to 5 nines, or I don't know, to 77. It doesn't really matter. So this is one way to think about the problem. But actually, you need to make sure that you're measuring things that are meaningful. And you need to make sure that actually it aligns with the things that, say, your CEO or your product manager would connect with. Internally, doing this improvement is a key part of our job, I think. Because it's kind of obvious that you want to move to the right before you move up, right? You find this irrelevant metric, and then you optimize and optimize and optimize it to 5 nines. You might have just wasted a bunch of effort. Charity Majors, @MipsyTipsy, that's her Twitter handle. She coined the phrase, nines don't matter if your users aren't happy. And I really liked it, so I wanted to credit her for that. I think it's 100% correct. The nines are about the business value that you provide customers. So really, it's not so much operations versus reliability, right? Like I know you're under pager fatigue and I know it's very difficult. It's really more about trading off cost and revenue, right? Like the additional reliability should be enabling your business to achieve a certain business goal. And I never even met your CIO or CEO, other than those who raised their hands, that they are the CIO, hi folks. But I'm almost certain that this is part of how they think, right? Like that's how we expect executives or MBAs or whatnot to think. Now let me connect this again to sort of like a more concrete example. You've been firefighting your server-side 500s, your HTTP 500s for months, right? Like you have a fleet of microservices, and not all of them have been hitting this goal that you've agreed on of 3 nines. You want to manage with SLOs. You're expecting every microservice to have 3 nines, and you've been fighting that for ages, and you're getting paid for this service and that service that is noisy, and over there the dev group is really annoying, and they keep doing like rollouts, and like it's all hot and messy. And after a while, you've decided to change the way that you measure reliability, and it's no longer about the nines of all of these microservices. It's sort of like about an end-to-end interaction, and you discover that actually the client retries many operations, and that some operations only cause a very mild degradation, or you work with your product management or UX to sort of like change the way the application behaves, and actually like this bit, it's good, but it's fine if it's only working 95% of the time. And you remove the alerts, and you have less operations. And you didn't sacrifice reliability, right? Like you're just doing less operations and you didn't harm a user. You've only changed the way you're thinking. You've moved the front. Alternatively, you've done an effort to improve measurements. My VP, Ben Traynor-Sloss, has a talk called Metrics That Matter from GCP Next 2017. You have to see this. He has an amazing story about how Gmail went through this process. Don't listen to me. Go see his talk. Anyway, how Gmail went through the process of changing how they measure reliability, right? Suppose you go to an end-to-end measurement, and you discover that when you actually look at the things that matter to a customer, checking out from your store, you need the interaction of all of these 25 different services, microservices, that all of them have 3 nines. But actually, 3 nines raised to the 25th power, something like 97.5. Oh my God, 97.5, quick, we need to page someone, we need to roll this back. There's nothing to roll back. This is how your service has been engineered for ages. Like, this is what it's been like for 6 months now. But you have now understood an opportunity. You can now maybe move to 98% success rate on checking out, or 99% success rate on checking out. So again, you're going to radically improve the customer experience and like radically improve revenue. No operations to be done here, right? Like, don't page anyone. There's nothing to roll back. It's been like this for ages. Sit down, finish the coffee, go start designing a better retry mechanism on your AJAX dispatcher or whatever it is in the client that you need to change. So why is this hard? It's hard because the scope that we're talking about, taking to the logical conclusion, is everything, right? Like your entire organization, your entire business unit has to think this way. And I think it's very difficult to do SRE, like proper SRE, to my mind at least, what I would consider to be proper SRE, what the SRE I aspire to be, without strong buy-in from executives. So CXOs in the audience, think about this, please. It's also difficult, right? Like, you have the buy-in and everyone agrees and everyone, like, you know, they want to do this and the product managers come to your meetings about the SLOs and everyone's happy. It's still very, very hard. It's just very, very hard. And we have to agree if the screw falls from the plane, is that an accident, or if it isn't an accident? And like, what kind of, like, if it's only Firefox users and only in a certain geo, like, what is that? Is that a failure or is that not a failure? So it can be very difficult to operationalize and reason about and measure. Much like measuring love is difficult, or measuring simplicity, or measuring commitment is difficult, right? Reliability is a complicated topic. It can be expensive. It can be expensive in human labor, right? Like to add all these measurements, to apply all these techniques. It can be sometimes expensive in resource costs, depending on the scales involved and the systems that you use, right? Like, these can be very big data sets that we have to crunch through. And it can be difficult because of misconceptions, I think, of the SRE role in itself, right? Like, some people may not agree with this, and they might be right, right? Like, we need to talk about what is SRE. But sometimes people say, what? Measure reliability, operationalize, the product manager comes to a meeting about, listen, aren't you just supposed to do the CI/CD and like call it a day? And these misconceptions are hard when they come from our dev partners or from our executives. I think they're hardest when they come from us. There's something about operational work that is exciting, and we all want to be superheroes, right? And save the users. And it's okay. Thank you for the people who are like nodding now, or are like shaking their head, right? But many of us would want to be a superhero. It's very easy to fall into a superhero complex and be like, but I can answer one more page, right? Like, yeah, maybe this page isn't important. It's not just hard, it's also good. It's good because engineering is a high leverage endeavor, right? And you could need fewer people, maybe better trained people, or maybe they'll be like working smarter, but you'll need fewer people, and you'll be able to reuse the result of what they're doing, right? Like you've changed the measurement, you've adopted the pattern. This is the gift that keeps on giving. It's different to recurring operational work. And I don't want to say that recurring operational work is like, I don't want to put it too much in a corner, but just we need to put it in the framing that is appropriate for it. It's one of the tools in our toolbox. It's not the thing, I think, that we do. The other thing is costs, right? Like you can also reduce cost this way, right? Like you can go to CEO and say, listen, we can be more efficient about this. That $15 million region, like, you know, the 25 people that you have adopting like that reliability pattern, or the 25 people that you have delivering new features that then users can't use because they're broken, right? Like if you did this thing more carefully, if you did this more lean, you could actually reduce costs. You'll spend more, but you'll actually also make a lot more. And finally, I think precision. Some levels of reliability I don't think can be achieved any other way, right? Like I came over here, like I flew over I think it's called the British Canal, the Irish Canal? Irish Sea, thank you very much. I didn't grow up in the UK, I've only been living there for 6 years. Anyway, I can describe that another time, my mom's English, whatever. Thank you, Morley. So I flew over the Irish Sea to get here. In the speaker notes, it says the Atlantic. And I didn't check that the pilot is very good, right? Like, it's not like I interviewed the pilot. I trusted my life in his or her hands. I don't even know who they were, right? And I didn't check that they know what they're doing. I just like, yeah, it's okay. Reliability engineers are saving me. It's not about having a better pilot. I don't know that they're better than the Red Baron of like World War I. I don't know that we actually have much better pilots. I think we have much better planes because of reliability engineering practices. And also these reliability engineering practices feed into the pilots, right? Like I do think these pilots go through a different set of training and they have different set of operating procedures. That's part of reliability engineering. Okay, so if I'm building an SRE team, I want to create an SRE team, what kind of skills do I need to hire? What kind of people am I looking for? I think there's kind of like the more fundamental, or I don't know if obvious is the right word, but yeah, SRE, you know, like the monitoring and the alerting and the capacity planning and the CI/CDing and all that stuff, like bring in the Prometheus and the Kubernetes, right? Like where's all that stuff? Yes, there's a large element of that. But then there's perhaps the more advanced, which I think we can also kind of like nod our heads very easily about, and like, yes, of course, system architecture and distributed algorithms and like the networking and operating systems, we need to really understand what we're doing, right? Like, yeah, I agree with that. There's a big chunk of that as well. But also, I don't know if this is more or less agreeable, the more pioneering, the more transformational, where it's saying, yeah, actually an SRE, they need to have some business acumen. They need to have a sense for product management, for data science, for finding those small cohorts of unhappy users and helping them, or like finding on this very large system that the only thing we know about it is that we feel like it has too many outages. And now like clarifying what is an outage and like bringing big data sets into this and figuring out where do the outages come from most and trying to solve that part. That is also an important skill, I think, for an SRE team to have. I'm not expecting all these things to be in one person. I'm not looking for like superhuman beings. It could also be in less than one person. It could be that the SRE is the person who's relying on the business acumen of the business people, but they have the understanding of the method and they have the conviction to bring them into the room and sort of like to speak their language and like make sure that that we can connect with the business. I think that tinkering with the rollouts or carrying the pager, these things aren't the things that make me an SRE any more that when I make coffee in the morning, it doesn't make me a barista, right? And the dev can also show up in the morning with their pager, after a sleepless night with a pager, and they can also like make coffee and they can also tinker with rollouts, right? That would make them an SRE either, or that would make them a barista either, right? The dev come to work because they want to produce new features, right? They want to create business value by creating new functionality. And the SRE comes to work in the morning because they want to measurably optimize reliability at cost, right? Because the reason they do what they're doing is that they want to come up with a chart that resonates with the business, and then they want to get to a certain point on the chart within constraints, right? That's how I think about it. That's how I think about, you know, the SRE that I'd like to be, or the core definition of SRE to me. An SRE is a specialist in this regard. I like specialist reliability engineer, coined by someone else, not me. And they're a specialist who pleases users by engineering their trust of the functionality that they have, right? Like making sure that they continue trusting the system to be reliable. Then being SRE has very little to do with a pager. You can be an amazing SRE without ever seeing a pager. You can be handling a pager all day long and rollouts and capacity management and so on, and maybe you're not thinking about how to measurably optimize reliability at cost, not connected to the business. So the SRE that I at least aspire to be is someone who has a measurement of reliability that is agreed by them and by their other stakeholders. The measurement is agreed by the other stakeholders, so it's tied to project priorities, right? Like, so if the measurement goes below a certain level, we do something. And sometimes we can imagine this being applied too forcefully. If it goes below the error budget, we cut the releases and no, if it goes below the error budget, maybe we need to have a meeting and decide on a new error budget, right? Like maybe we give management the control and we say, listen, this is where you are. It's less than where you said you want to be. You should pay attention to you like slipping, just like you noticing that you're slipping on your sales targets or you slipping on anything else. And now tell me, where should we be aiming? Like, what is the right level of reliability? Because we've built a certain language around it. And your ops work is tied to that measurement, right? If the executive says, you know what, you're right, we shouldn't be aiming for that much latency, we should be aiming for that much latency, or you know what, you're right, we shouldn't be aiming for this many nines, we should be aiming for that many nines. This should feed into your operational work immediately, right? Like suddenly you have a much bigger envelope to work within. I'd like to see way fewer alerts. I'd like to see way fewer like human toil around these things. Otherwise, maybe we can do better. Otherwise, maybe we can further converge the decision-making loop, further tie things together. You're systematically aligning customer pain, customer unhappiness with reliability, and your operational work, and the way that you measure reliability. And if you can't answer a question like, what is the price of a page, right? Like if you're getting paged, what does that mean in the next quarter for your business priorities? What is the price of a page in terms of user harm? How many users need to be harmed, and how much for you to be paged, for a human to be paged? Maybe you can systematize more, right? Like, and if whomever controls the feature backlog doesn't recognize these measurements, maybe you can systematize more. But this is the SRE that I aspire to be. And it's a fairly new profession. And I'm very keen to hear your opinion. You can reach out to me during the conference. I'll be here today and half tomorrow. You can reach out on Twitter. It's not that hard to find my email address. I'd love to hear from you, right? Like I'd love to see that. I hope that in 5 years' time, or in 10 years' time, or maybe next year, we'll all be in SREcon, and we're like, oh, well, we all agree. Like we have exactly the same definition for SRE. This was my pitch. I hope you liked it. Please enjoy the conference. Thank you, everyone, for coming and being a great audience. Yeah, thank you very much.